Hello friends, welcome to the chapter 4 of Methods and Techniques for Business Data Analysis, that is Indices and Exponents. So coming to what is indices or exponents. So it can be expressed as an exponent is a number that indicates how many times you should multiply a number to itself. So here you have different forms of exponents where you can understand the concept very easily. The first different form of exponent are positive exponents. So positive exponents is nothing but the number should be positive. So here you can find out a number 2 has been taken. So 2 is multiplied 5 times. So that means 2 to the power of 5. So here 2 is been raised to the power of 5. So if it is written in the form a to the power of n, so then this 2 if multiplied 5 times, so this is written in the format 2 to the power of 5. So this is nothing but the positive exponents, only positive number has to be taken. The second one, negative exponent. So in negative exponent you have a rule, a should not equal to be 0 and n should be a positive integer. So if this is the rule, so if a is to the power of minus n, so this can be written as 1 divided by a to the power of n. So if a to the power of minus n is there, so this can be written as 1 divided by a to the power of n, where in denominator n will become positive. So in the same way, if it is a to the power of n is equal to 1 divided by a to the power of minus n, so here in denominator the positive will become negative. In zero exponents, anything expressed to the power of 0 is called as 1. So 0 power 0 is meaningless. So any number other than 0, if it is expressed to the power in the form of 0, then it is being called as 1. Next one, fractional exponents. So in fractional exponents, you will find out what is root and cube. So if there is nothing, if you have just root a, so this can be written as a to the power 1 by 2. So but here if you have cube a, root cube a, that is a into 1 by 3. So whenever you have cube, make sure you are writing 1 by 3. Whenever you have square, you are writing 1 by 2. In the same way, a 4 by 5, so this can be written as root a4, a to the power 4. So here in the place of root you can write as 5. So this denominator for 5 shall be written here, and this numerator 4 should be written in the inner column. So make sure these are the different types of components. So exponents, how you have to write the above thing. So here you have law of indices. So if it is an product law, product is nothing but multiplication. A to the power m into a to the power n is equal to, so once it is been a product law, so this multiplication will be added. Why? Because a is a base and you have powers as different powers, so only powers will be added and the base will be same, a to the power m plus n. So here there is an example, 2 square into 2 cube is equal to 2 to the power 2 plus 3 is equal to 2 to the power 5. So where 2 power 5 is 32. So when it comes for quotient law or division law, a to the power m divided by a to the power n is equal to a to the power m minus n. So whenever you have a division, you will subtract here. So 2 cube divided by 2 square is equal to 2 to the power 3 minus 2, where you got 2 to the power 1, that is 2. Next, coming to power law, a power m to the power of n. So this can be written as m into n. First you multiply this, so you will get a to the power mn. So coming to the power law, once again, a into b to the power of m. So a into b to the power of m is equal to a to the power m into b to the power m. So whenever you have like this, so this can also be written as a divided by b to the power of m. So further, a to the power m divided by b to the power m. Why? Because this m is common for both a and b, so that is why we are writing as a to the power m and b to the power m. So these are the different law of indices where we will come into function. So here there are few problems to make sure how you are supposed to solve by using this law of indices. So here you have a problem 243 minus 3 by 5. So the power is minus 3 by 5. So 243 you have to take an LCM. So go with the smallest number. 3 is the smallest number. So once you are done, so you will get 2, 3, 4, 5. Totally 5 threes you will get. So whenever you have negative, so this can be written as a to the power minus n can be written as 1 divided by a to the power n. Please have a look here. A to the power minus n can be written as 1 divided by a to the power n. So in the same way, 243 to the power minus 3 by 5 can be written as 1 divided by 243 to the power 3 by 5. So minus will become plus when it comes to denominator. So this 243 can be written as 3 to the power of 5. So 1 divided by 3 to the power of 5 to the power 3 by 5. So this 5 and this 5 will get cancelled. So 1 divided by 3 power 3. So 3 to the power 3 is 27. So the final answer will be 1 divided by 27. Next problem. 4 to the power minus 1 by 3 whole power 2 to the whole power minus 3 by 4. So here you have brackets. So you have to remove one bracket separately and then you have to solve the problem. So first this 4 can be written in the form 2 square. So we have written as 2 square to the power minus 1 by 3 to the power of square and to the whole power of minus 3 by 4. So once again you have 2 here. This 2 into this minus 1 by 3 you have to multiply. 2 ones are 2. So minus 2 by 3 to the whole power 2 to the whole power minus 3 by 4. It will continue. For the next step, minus 2 into 2 will become minus 4 divided by 3 to the whole power minus 3 by 4. So here you have 4 by 3 and 3 by 4. So 3 ones are 3 and 4 ones are 4. It will get cancelled. Why? Because it is a cross multiplication. So 4, 4, 3, 3 it will get cancelled and the even minus will get cancelled. So it will be remaining with something called 1 here. So anything to the power of 1 will be the same value. So 2 power 1 will be 2. Next problem. 64 to the power minus 5 by 6 divided by 27 to the power minus 1 by 3. So division. 64 can be written in the form 2 to the power of 6 to the power minus 5 by 6. 27 can be written as 3 to the power of 3 to the power of minus 1 by 3. So here 6 and 6 is common. So eliminate that. 3 and 3 is common. Eliminate. So you are remaining with 2 to the power of 5 and 3 to the power of 1. So come with the law. 2 to the power of 5, that is a to the power of minus n, can be written as 1 divided by a power n. So 1 divided by 2 power 5 and 1 divided by 3. So 1 divided by 2 to the power of 5 into. So here you have a denominator. So this 1 by 3 is the whole denominator. In this denominator, 1 is a numerator and 3 is a denominator. So this 3 will go to numerator and 1 will be in the place of denominator. So 1 divided by 2 to the power of 5 into 3 divided by 1 is equal to 3 divided by 32. So 3 ones are 3, 2 power 5 is 32, 32 into 1 will become 32. Whenever it is a multiplication, there is no need of LCM and all. So directly you can do the following. Next problem. 32 to the power minus 2 by 5 divided by 125 to the power minus 2 by 3. Once again the same rule. So 32 can be written as 2 to the power 5 minus 2 by 5. So 125 can be written as 5 power 3 to the power minus 2 by 3. So the same terms will get cancelled. 5 and 5 will get cancelled. 3 and 3 will get cancelled. You are remaining with 2 power minus 2 and 5 power minus 2. So this can be written in the form 1 divided by 2 square, 1 divided by 5 square. So 1 divided by 2 square is nothing but 1 by 4 into. So instead of writing 1 by 25, so this should be written as into 25 by 1. So 25 divided by 4 is your answer. Next problem. 3 power 4 minus 4 divided by 2 power minus 8 to the whole power of minus 1 by 4. So the first thing is 3 power minus 4 can be written as 1 by 3 power 4 and 1 by 2 power 8 to the whole power of 1 by 4. So this further will be written as 1 divided by 3 power 4 into 2 power 8 divided by 1 to the whole power of 1 by 4. So now if you multiply this, you will get 2 power 8 divided by 3 power 4. So this 2 power 8 can be written as 2 square into 4. So this 2 into 4 will become 8. So why we have written as 2 into 4 only? Why? Because here already you have 1 by 4 to the whole power. So this 4 and here this 4 to we should cancel. So only because of this we have written as 2 square to the power 4. That means 2 into 4 will become 2 power 8. This is the only reason why we have written like this. So next step will 2 square divided by 3 to the whole power 4 to the whole power of 1 by 4. So here 2 square is 4, 4 divided by 3 to the whole power of 4 ones are 4, 4 divided by 4. So anyways if you cancel 4 and 4 it will be 1, or else 4 ones are 4 divided by 4. So 4 by 3 to the power 4 by 4. So you will get 4 by 3 itself. Why? Because anything to the power of 1 will be the same number what you are writing. Next problem. 3 cube into 243 into to the power of minus 2 by 3 into 9 to the power minus 1 by 3. So 3 cube is written as 3 cube itself. 243 as you have minus. So according to the law you will write as 1 divided by 243 to the power 2 by 3. And once again for 9 to the power minus 1 by 3 it is written as 1 divided by 9 to the power 1 by 3. So 243 can be written as 3 to the power 5 and 9 is written as 3 square. So 3 cube into 1 divided by 5 into 2 will become 10 divided by 3. So 3 to the power 10 by 3, and once again 2 ones are 2 and divided by 3. So 3 to the power 2 by 3. So here what you have is am into an. So this can be written as a into a to the power m plus n. So this 3 cube will become numerator divided by 3 to the power 10 by 3 plus 2 by 3. So how means they have multiplied 3 cube into 1. So it will become 3 cube divided by 3 to the power 10 by 3 plus 2 by 3. So this is how they have taken analyzed. So 3 cube divided by, so 3 and 3 you have a same base. So directly you can add the numerators. 3 to the power 12 by 3. So 3 cube, so 3 ones are 3, 3 fours are 12. So here you will get 3 to the power of 4. So here you have 3 cube and here you have 3, 4. So whenever you have a to the power m and a to the power n, so this should be written as a to the power m minus n. How to write, sir? So you will get 3 to the power 3 minus 4. So this should be written according to this exponent law of indices. So this can be written as 3 to the power 3 minus 4, where you will get 3 to the power minus 1 in the next step. So anything to the power of minus 1 should be written as 1 divided by 3. So here 3 cube divided by 3 to the power 4. So next step will be 3 to the power 3 minus 4 according to this rule. So then you will get 1 divided by 3. Why? Because you will get 3 to the power minus 1. Or else directly you can make sure. Why? Because 3 minus 4 is minus 1. So you are directly taking 1 divided by 3 to the power 4 minus 3. So if you have denominator as the highest, so you should make sure that you should write in the form of 1 divided by, that is according to this law. So you will get 1 divided by 3 to the power 4 minus 3 is equal to 1 by 3. So go with any of the methods which I have informed. Next problem. 5 to the power minus 4 into 125 to the power 5 by 3 divided by 25 to the power of minus 1 by 2. So first you have to multiply and then you have to divide. 5 to the power minus 4 into 125 to the power 5 by 3 divided by 25 to the power minus 1 by 2. This 125 is written as 5 cube to the power 5 by 3. 25 is written as 5 square to the power minus 1 by 2. Here 3 3 and 3 is common, so eliminate that. 2 and 2 is common, eliminate. So next step will become 5 to the power minus 4 into 5 to the power 5 divided by 5 to the power minus 1. So whenever you have a to the power m into a to the power n, so this can be written as a to the power m plus n. So 5 to the power minus 4 plus 5 will become 5 to the power minus 1. So next step, minus 4 plus 5 will become 1. So 5 to the power 1 divided by 5 to the power minus 1. So whenever you have division, so it should be written as a to the power m minus n. So 5, 1 minus of minus 1. So in denominator you have minus 1. In numerator you have 1. So how you are writing as, you are taking the base 5, this 1 minus of minus 1. So it will become plus 1. So 5 square, which will be 25. So according to this law of indices, you will write this equation. Next step. So totally you have 3 cube roots a to the power 12. So be careful here. So first you should take this root a 12. So this is in the form of cube. So in flower brackets, a to the power 12 to the power of 1 by 3. Why? Because you have a cube. So this is been written as 1 by 3. And once again you will write roots, 2 roots. Next, once again root 3, then here 3 1s are 3, 3 4s are 12. So here you will get a to the power 4. Once again a to the power 4 to the power 1 by 3. Why? Because you have taken one root, so you are writing as 1 by 3, and there will be one more root. And once again a to the power 4 1s are 4 divided by 3. So 4 divided by 3. So root will be there as usual. A 4 by 3 to the whole power of 1 by 3. So this root has been taken out. So here what it will become is 4 1s are 4, 3 3s are 9. So a to the power 4 by 9. So here each and every root is taken separately. So whenever this root is being taken out separately, so whenever you have a cube root, so there we are writing as 1 divided by 3. So that's the only difference what you are looking for. So whenever you have cube root, so it is been eliminated separately and you are writing that as 1 divided by 3. Next problem. 5 into 25 to the power n plus 1 minus 25 into 5 to the power 2n divided by 5 into 2n plus 3 minus 25 into n plus 1. So 25 is written as 5 square and 25 is written as 5 square. So wherever you have 25, it is written as 5 square. So 5 into 5, this 2 is multiplied with the power 2n plus 2. Why? Because 2n plus 2 ones is 2. Next, 5 square into 5 to the power 2n. Once again here also it will be the same rule, 2n plus 2. So this 5 is common for 2n and as well as for 2. So this can be written as 5 to the power 2n into 5 square. Why? Because a to the power m plus n can be written as am into an. So in the same way, 5 to the power 2n into 5 square minus 5 square into 5 to the power 2n, and once again 5 to the power 2n plus 3 can be written as 5 to the power 2n into 5 to the power 3 minus 5 to the power 2n into 5 to the power square 5 square. So whenever you have a to the power m plus n, so that can be written as a to the power m into a to the power n. So take the common terms, 5 to the power 2n and 5 square is common in both numerator and denominator. So the remaining will be 5 minus 1, and here also it will be 5 minus 1. So once you take the common terms, so cancel this and you have only 4, and once again 5 minus 1 is 4. So 4 ones are 4. So 1 will be the answer for this sum. 3 to the power n plus 2 minus 3 to the power a plus 2 minus 3 to the power a plus 1 divided by 4 into 3 power a minus 3 power a. So 3a to the power m plus n can be written as a to the power m into a to the power n. So this can be written as 3 to the power a into 3 power 3 square minus 3 power a into 3 to the power 1. It's nothing but 3 itself. So once again the denominator, however, you have write in the same way. So what is common? 3 power a is common, and once again here also in denominator 3 power a is common. So 3 to the power a, the remaining will be 3 square minus 3. So here 3 power a you have taken as common, 4 minus 1. So 9 minus 3 divided by 3, because common terms will get cancelled. 6 by 3 will be 2. So 2 will be the answer for this overall sum. Next one, a plus b to the power minus 1 into a to the power minus 1 plus b to the power minus 1. So anything to the power of minus n can be written as 1 divided by the follow numbers. So 1 divided by a plus b. So a power minus 1 is written as 1 by a, b power minus 1 is written as 1 plus b. So 1 divided by a plus b, here a and b you have, so this is been taken as LCM. AB will be the LCM, so here it will become b plus a. So b plus a and a plus b is both one and the same, cancel that. So you are remaining with 1 divided by ab, so where 1 divided by ab is the answer. So next problem, a power m divided by a power n to the whole power of m plus n. So this can be written as a power m divided by a power n can be written as a to the power m minus n according to the law of indices. So we have written as a to the power m minus n to the whole power of m plus n. Once again here also it's the same thing, a power n minus 1 to the whole power of n plus 1. So a to the power 1 minus m to the whole power of 1 plus m. So everywhere a is the common base which has been taken. So a to the power m minus n into m plus 1. So for this m minus n into m plus 1, n minus 1 into n plus 1, once again 1 minus m into 1 plus 1. So everywhere a is the common terms which we have taken. So a plus b, a minus b formula will be a square minus b square. In the same way m minus n into m plus n can be written as a to the power m square minus n square, a to the power n square minus 1 square, a to the power 1 square minus m square. Everywhere it is written as the same. When you have a common base, powers can be equated. So a is the common base, m square minus n square plus n square minus 1 square plus 1 square minus m square. So everything get cancelled, and finally you will be remaining with something called 0. So anything to the power of 0 is called as 1. This is also the same rule, x to the power a divided by x to the power b to the power a square plus ab plus b square, and once again you have a same thing. So what you are supposed to do is x to the power a minus b to the whole power x to the power b minus c the whole power x to the power c by a into the whole power. So this a minus b into this power has to be multiplied, b minus c into this power has to be multiplied, c minus a into this power has to be multiplied. So this is according to the equation a cube minus b cube. So a cube minus b cube can be written as a minus b into a square plus ab plus b square. So everywhere you can see the same thing, a cube minus b cube minus c cube, and c cube minus a cube. So whenever you have the same base, so base can be taken as 1 and power should be added. So these powers, when it is being added, so everything will make sure it will be in the form of 0. So anything to the power of 0 will be 1. So even sum 15 is according to the same way. So you can try out and you will get the answer as 1. So according to the same rule of 14th. Next problem. Root of x power b divided by x to the power c to the into ca to the root of x power c divided by x power a, and next is root ab of x a divided by x to the power b. So this is written as x power b divided by x power c into, as you have a root here, so you are writing it as 1 divided by bc BC. Here also it's the same way, 1 divided by CA, and here also it's the same way, you are writing as 1 divided by AB. AM divided by AN can be written as A to the power M minus N. So x to the power B divided by x to the power C can be written as x to the power B minus C into to the whole power 1 divided by BC. Here also it's the same way you have to follow. B minus C into 1 will become B minus C divided by BC. C minus A divided by CA, x to the power A minus B divided by AB. So once again x is the common thing for all. So x to the power, add everything which is there in powers. So B minus C divided by BC plus C minus A divided by CA plus A minus B divided by AB. So x to the power, take the LCM. So BC, CA and AB. ABC will become the LCM. So here you have BC. Eliminate this BC, and for the first one, A into B minus C. So here C minus A is there, so B is not there. So B into C minus A plus A minus B is there, C is not there. So plus C into A minus B. So according to the LCM, you make sure you find this. X to the power A into B will become AB minus A into C will become AC plus B into C will become BC minus B into A will become BA. So in the same way you write. So then you will get the common terms, eliminate everything. X to the power 0 divided by ABC will become 0. Anything to the power of 0 will become 1. Next problem. If P1 by X is equal to Q1 by Y is equal to R1 by Z and the whole PQR value is 1, so you should prove that X plus Y plus Z is equal to 0. So this given term is to be considered as K. If P1 by X is considered as K and Q1 by Y is called as K and R1 by Z is considered as K, so this P1 by X, what we are supposed to do is, so to the whole powers we have to multiply with the same power. P to the power 1 by X to the whole power of X. So here also X will be added is equal to K to the power X. Why? Because we have to make sure we are proving it as 1. So because we are following with the same rule. Once again, Q to the power 1 by Y to the whole power of Y to the power of K to the power Y. R to the power 1 by Z to the whole power of Z is equal to K to the power of Z. After doing this, x and will get cancelled, y will get cancelled, and z will get cancelled. So P is equal to K to the power X, Q is equal to K to the power Y, and R is equal to K to the power Z. So if PQR is 1, so P has a value K power X and Q has a value K power Y and R has a value K power Z is equal to 1. So K is the base, so K to the power X plus Y plus Z is equal to 1 is written as K power 0 because anything to the power of 0 will be 1. So as the base is K, here also we have taken K to the power 0. So both bases are same, only powers has to be considered. X plus Y plus Z is equal to 0. So here you had to prove that X plus Y plus 0 and hence prove the sum. So whenever you get these type of problems, be careful. So write everything. So here you have to consider something. So consider any alphabetical value. So here we have taken as K. So anything is to be in the form of K. And finally this number, the 1 by X, the alphabetical value or the variable. So this has to be in the power. So when power get cancelled, so then you will get the answer correctly what they have asked for proved. Next problem. So here you have to prove XA is equal to Y to the power B is equal to Z to the power Z is equal to K, where you have to prove AB plus BC plus CA. So once again it is to the form of K. So here you have only X power A. So you are writing as 1 by A. Why? Because A and A should get cancelled and K to the power 1 minus A. So here you have just X to the power A. So that is why you are writing as X to the power A into to the power of 1 by A. So X can be written as K to the power 1 by A. In the same way for Y, K to the power 1 by B, and for Z, K to the power 1 by C. So now you have xyz is equal to 1. So x has a value k to the power 1 by a, 1 by b and 1 by c. You will write the same thing is equal to 1. So once k as the common base, k to the power 1 by a plus 1 by b plus 1 by c is equal to k to the power 0. As you have a common base, so bases will not be taken, so here power should be considered. 1 by a plus 1 by p plus 1 by c is equal to 0. So abc is the LCM, so in numerator bc plus ac plus ab is equal to 0 according to the LCM. So here in the first one I will help you out. A is there, so in the whole ABC cancel this A, so you are remaining with BC. So BC into 1 will become BC. In the same way do for B and do for C, you will get AC plus AB. So when you add this, BC plus AC plus AB will become AB plus BC plus AC. So this will come into an order according to what they have asked for proved. So this should be written according to AB plus BC plus AC. So then ABC into 0, the cross multiplication when you are doing, it will become 0 itself. So that is why AB plus BC plus AC hence proved. So just orders has been changed here. So other than that, the everything is same. But this has to be cross multiplied to the value. So anything multiplied by 0 is 0 itself. Next problem, 9 into 3 power x is equal to 27 to the power 2x minus 5. So whatever is there in question, you will write the same thing. 9 can be written as in the form of 3 square into 3 power x. 27 is written as 3 cube to the power 2x minus 5. 3 to the power, whenever it is in the multiplication form, am into an, so this can be added. So 3 to the power 2 plus x is equal to 3 into 2x will become 6x, 3 into 5 will become minus 15, 3 to the power 6x minus 15. As the bases are same, only consider the parts. 2x plus x is equal to 6x minus 15. So take this x into common and numbers into common. So minus 15 will become plus 15. This plus x will go for RHS, it will become minus x. 5x is equal to 17, x is equal to 17 5 by. So here you have to solve for x when they are asking only for x. So here you have to simplify. 9 to the power 3 by 2 minus 3 to the power 7 by 7 to the power 0 minus 1 by 81 to the power 1 by 2. So 9 to the power 3 by 2 is written as same. Anything to the power of 0 is written as 1. So 3 into 1 minus 1 by 81 is written as 81 to the power 1 by 2. Why? Because you have minus here. So that is why we are converting this to the form 81 to the power 1 by 2. So 9 can be written as 3 square e to the power 3 by 2. So this is written according to the same. And 81 is written according to that value 3 power 4 to the power 1 by 2. 2 and 2 will get cancelled. You are remaining with 3 cube. 3 ones are is 3. 2 ones are 2 twos are 4. So it will get cancelled here. 2 ones are 2. So once again you have a balance 3 square. 3 cube is 27. 3 minus 3 square is 9. 27 minus 3 minus 9 will get you the value as 15. So here after simplifying you have got a value as 15. So this problem, root 4 cube to the power 2x plus 1 by 2 is equal to cube 8 to the power 5. So whenever you have these type of problems, so in the power itself it is in the plus. So whenever you have this addition symbol, so take LCM. 2 is the LCM. 2 2s is 4. 4x. 4x plus 1 divided by 2. So here you will write the same thing. Here also you will write the same thing. In the next step, 4 to the power 1 by 3 to the whole power of 4x plus 1 divided by 2. So here 8 to the power 5 to the whole power of minus 1 by 3. Why? Because you have a root here according to this step. So 4 to the power of 4x plus 1, the same thing will be there, divided by 2 3s will become 6 is equal to 8 to the power 5 divided by 3. 5 1s are 5 divided by 3. So 4 can be written as 2 square. So 4x plus 1 by 6 will be there. 8 can be written as 2 cube. Why? Because everything we are taking in the form of 2. So 8 is written as 2 cube to the power 5 by 3. Here 3 and 3 will get cancelled. Here 2 1s are 2, 2 3s are 6. So remaining is 2 to the power 4x plus 1 divided by 3 to the power of 5. As the bases are equal, that is 2 and 2 is equal, so 4x plus 1 divided by 3 is equal to 5. Only these powers has been taken into consideration. 4x plus 1 is equal to 3 into 5 will become 15. 4x is equal to 15 minus 1, that is 14. X is equal to 14 by 4. So you will get the answer as x is equal to 7 by 2. So here you have 2 to the power x is equal to 3 power y is equal to 6 to the power minus z is equal to k. So here you have to prove that 1 by x plus 1 by y plus 1 by z is equal to 0. So anything, as I told earlier, so whenever you have anything for proof, so make sure it should be written for any of the alphabets. Take it as k or take it as any value. So 2x is equal to k, 3y is equal to k, and 6 to the power z is equal to k. So 2 to the power x, so to the whole power of 1 by x. Once again for k to the whole power of 1 by x. Whatever value you have, you should take the power with the same value. So x and x will get cancelled. 2 is equal to k to the power minus 1 by x. So take the same thing for everything. Even for here also 3 is equal to k 1 power y, and here you, as you have minus, so this will become 6 is equal to k to the power minus 1 by z. So here you have to be careful. So 6 is equal to k to the power minus y by z. So this is having minus symbol, so this is taken into consideration. So here you have 6. So 2 into 3, if you multiply, it will become 6. So here you have 2, here you have 3. So we have taken 6 is equal to k to the power minus 1 by z. To get 6, we have to multiply 2 into 3, which is already given, is equal to k to the power minus 1 by z. So for 2 you have a value, for 3 you have a value, substitute, is equal to k to the power minus 1 by z. So once again, as you have a same base, so powers can be added. K to the power 1 by x plus 1 by 5 is equal to k to the power 1 by z. So now all the bases have become equal. Here also you have k, and here also you have k. 1 by x plus 1 by y is equal to minus 1 by z. So when this RHS come to LHS, 1 by x plus 1 by y plus 1 by z is equal to 0. So this is how powers will be equated, and finally you have proved 1 by x plus 1 by y plus 1 by z is equal to 0. So these are the different type of application problems what you can find in indices or an exponents. So make sure you know the laws of indices and exponents, and you should be knowing what are the different kinds of indices and how it has to be used when it is being a multiplication or when it is being addition or an division. So these are the basic things which you have to learn, and you will find out with a very good results. Happy learning. Thank you.